What if Earth is not pulling you down in the way you imagine? What if gravity is not just an invisible force? What if gravity is something much stranger? Every day we feel gravity. If we drop something, it falls. If we jump, we come back down. If we throw a ball upward, it returns to Earth. So we naturally think Earth is pulling everything down. And for normal life, this idea works. Long ago, Sir Isaac Newton explained gravity as a force. He said objects pull each other. Earth pulls us. Earth pulls the moon. The sun pulls Earth. This explained many things. But one question remained. How does the sun pull Earth from so far away? There is no rope between them. There is no giant hand holding Earth. There is nothing visible connecting them. So, what is really happening? For more than 200 years, Newton's idea worked beautifully. But then, Albert Einstein looked at gravity in a completely different way. He asked a strange question. What if gravity is not only a pull? What if gravity is connected to the shape of space and time? That sounds difficult. But Einstein reached this idea by imagining something very simple. A falling man. Einstein liked to imagine strange situations. One day, he thought about a man falling from a roof. That sounds scary. But Einstein was not thinking about the danger. He was thinking about the feeling during the fall. Imagine a person falling freely. For a few seconds, he does not feel his weight. There is no floor under his feet. No chair is pushing him upward. No scale is showing his weight. He feels almost like he is floating, just like an astronaut in space. But here is the strange part. From the ground, we see him falling. We say gravity is pulling him down. But from his own feeling, he is almost weightless. So Einstein asked, if the falling person feels weightless, then what is gravity really doing? This gave him a big clue. Maybe falling and floating are not completely different. Maybe they are deeply connected. And this idea led him to an even stranger thought. A closed room. Now imagine this. You're inside a small, closed room. There are no windows. You cannot see outside. You do not know where the room is. At first, imagine this room is standing on Earth. You stand on the floor. The floor pushes against your feet, so you feel your normal weight. Now imagine something different. The same room is far away in deep space. There is no Earth nearby, no planet, no gravity pulling you down. If the room stayed still there, you would float inside it. Your feet would not stay on the floor. You would feel weightless. But now imagine the room is actually inside a rocket. The rocket starts moving upward, faster and faster. Because the rocket is pushing upward, the floor presses against your feet again. So you feel weight again. It feels almost the same as standing on Earth. Now the big question is, can you know the difference? Are you standing in a room on Earth? Or are you inside a rocket moving faster and faster through space? If there are no windows, you cannot easily tell. This was one of Einstein's greatest ideas. Gravity and acceleration can feel the same. But Einstein did not stop there. He asked one more question. If a moving rocket can feel like gravity, then what happens to light inside that rocket? Imagine you are inside that rocket. The rocket is moving upward, faster and faster. Now you turn on a flashlight from the left wall inside that rocket. The light starts moving toward the right wall, but light needs a tiny moment to cross the room. During that tiny moment, the rocket itself moves upward. So when the light reaches the right wall, the wall is not exactly where it was before. The rocket has moved. That means the light may hit the opposite wall a little lower than expected. Not because the light is falling down, but because the rocket moved upward while the light was traveling sideways. To a person inside the rocket, the path of the light would look slightly curved. Now Einstein made the big connection. If acceleration can make light appear to bend, and if gravity feels like acceleration, then gravity should also bend light. But this created a mystery. Light has no weight like a stone or a ball. So why should gravity affect light? Einstein's answer was very different. He said gravity is not simply pulling the light down. Instead, big objects like the sun change the shape of space and time around them. Light travels through that changed space and time, so the path of light looks bent. This was a huge idea. Gravity does not only affect apples, people, and planets. Gravity can also affect light. But how can space and time change shape? To understand that, imagine a stretched cloth. Imagine a piece of cloth stretched tightly. Now place a heavy ball in the middle. The cloth bends downward around the ball. Now roll a small marble near the heavy ball. The marble will not move in a perfectly straight line. It will follow the curve of the cloth. The heavy ball is not pulling the marble with a rope. The cloth itself has changed shape. The marble is simply following that changed shape. This is not exactly how the universe works, but it helps us imagine Einstein's idea. In a similar way, the sun changes the shape of space and time around it. Earth moves through that changed space and time. So Earth is not simply being pulled by the sun like a rope. Earth follows the curved path around the sun like the marble. That curved path is what we call an orbit. So, in Newton's picture, the sun pulls Earth. But in Einstein's deeper picture, the sun changes the shape of space and time, and Earth follows that shape. Scientists often call this combined idea spacetime. This is why planets move around stars. This is why light can bend near the sun. And this is why gravity is much stranger than it first appears. But a beautiful idea is not enough. Science needs proof. So how could Einstein prove that space and time really bend? The answer came during a solar eclipse. Einstein's idea sounded almost impossible. Many scientists did not believe it at first. That is understandable. Newton's theory had ruled science for more than 200 years, so Einstein needed evidence. His theory made one clear prediction. If the sun bends space and time, then light from distant stars should bend when it passes near the sun. But there was a problem. The sun is too bright. Normally, we cannot see stars close to the sun. So scientists needed a total solar eclipse. During the solar eclipse, the moon covers the sun. The sky becomes dark, and stars near the sun become visible. In 1919, scientists took photographs during a solar eclipse. They looked at the stars near the sun, and they found something amazing. The stars appeared slightly out of place. But the stars had not really moved. Their light had changed direction while passing near the sun. That is why, from Earth, the stars look shifted from their normal positions. Einstein's prediction was correct. The world was shocked. Einstein became famous, and gravity was no longer just a simple pull. It became something deeper, a bend in space and time. So, what is gravity? In everyday life, we can still say gravity pulls things down. That is simple, that is useful. But Einstein showed a deeper truth. Gravity is connected to the shape of space and time. The sun changes space and time around it. Earth follows that curve. Light also follows that curve. Even time itself can change near strong gravity. So, when something falls, when the moon circles Earth, or when Earth moves around the sun, they are all following the same hidden rule. They are moving through curved space and time. And the strange part is this: you are feeling that curve right now. The floor under your feet is pushing you upward. Earth is changing the shape of space and time around you. And your body feels that as weight. That feeling is what we call gravity. Einstein did not just explain why things fall. He changed the meaning of falling itself. And if gravity can change space and time, then the next question is even stranger. Can time itself slow down? That is a story for another video. If you enjoy simple science like this, subscribe to this channel.